Welcome to this exciting session on LangGraph, where we'll dive into how you can build powerful AI systems with memory and context and create intelligent applications that don't forget the conversation. LangGraph allows you to create stateful workflows, meaning your AI systems can remember user interactions and adjust accordingly. Whether you're working on chatbots, personal assistants, or any other kind of AI system, LangGraph will help you create an intelligent and adaptable framework. In this session, we'll explore how LangGraph works, why it's a great tool for AI development, and how you can start using it for your own projects. We will also touch on some real-world applications and share best practices for building efficient AI workflows. By the end of this tutorial, you'll have a solid understanding of how to get started with LangGraph and be ready to build your own projects. So here is the agenda. Here's what we will cover in this session. What is LangGraph? Where you can learn why it's a game changer in the world of AI systems. LangGraph versus LangChain. You can understand the differences between LangGraph and other popular frameworks like LangChain. How LangGraph works, discover the core components, nodes, edges, and state, and how they work together to create intelligent AI workflows. Building your first LangGraph. Step-by-step guide to setting up your first LangGraph project and creating your first memory-enabled assistant. Advanced features. Learn how to handle decision-making, conditional jumps, and multi-round conversations. Integration with external tools. See how LangGraph works seamlessly with tools like Pinecone and Hugging Face to add extra capabilities to your AI projects. Debugging and optimization. Best practices for troubleshooting common errors and optimizing performance for smoother AI workflows. Before we dive into the technical details, I want to highlight an amazing course that will help you build on these concepts. So let's pause for a quick quiz question to test your knowledge so far. Here's the question. What do you think are the key components that make a LangGraph workflow? Is it A, nodes, edges, state, B, functions, loops, and variables, C, data process output, or D, arrays, conditions, and loops? Take a moment to think about it. I'll give you the correct answer in just a bit. Let's kick things off by understanding what LangGraph is and why it matters in the world of AI development. Imagine you're speaking to a chatbot, asking it questions about your day or looking for some help. It responds quickly, but then suddenly it forgets what you just said. Sounds familiar, right? This is a common problem. Traditional chatbots or assistants respond to a single query but lack the ability to maintain context across multiple interactions. This can lead to confusing, disjointed conversations that frustrate users. This is where LangGraph steps in. LangGraph is a framework designed to give your AI system memory. It's built around stateful workflows, meaning it helps your AI remember past interactions and adapt responses based on that information. If you think of it like a GPS, LangGraph helps your AI remember the route that it's taken, making it capable of adjusting its next steps based on what's happened earlier in the conversation. So why does this matter? Let's look at real-world use cases. Imagine an HR assistant that remembers a candidate detail through an interview process, or a travel planner that remembers your preferences, past trips, and budget for better suggestions. These are just a couple of examples where LangGraph's ability to keep track of conversations and adapt is essential. We shall now move on to LangGraph versus LangChain. We'll also mention LangChain briefly because it's another popular framework that's commonly used in AI. But LangGraph is different. LangGraph is all about stateful interactions like map that tracks your entire journey. LangChain, on the other hand, is more like a set of tools that's chaining together different AI models. It's great for simple tasks, but LangGraph gives you more control over multi-step workflows and complex conversations. We shall now move on to debugging LangGraph applications. As you dive deeper into LangGraph, you will inevitably face challenges and errors. Debugging is a vital part of software development, and it's a skill that helps you understand how applications work. Identify where things go wrong and find solutions. In this chapter, we'll explore common errors that you might encounter in LangGraph and how to solve them, and the best practices for troubleshooting and debugging your workflows effectively. So debugging is the process of figuring out why something isn't working as expected and fixing it. Think of it like a detective job. Just like a detective looks for clues to solve a mystery, you need to track the flow of data, pinpoint where things went wrong, and figure out how to correct it. This process helps you understand your application's behavior, find bugs, and improve its performance. When you're working with LangGraph, you may run into a situation where AI might not respond as expected, or a node might not be triggered properly. This is when debugging becomes essential. Fortunately, LangGraph provides various tools and strategies that make this easier. Let's dive into some common errors that you will likely face and how to solve them effectively. So here are some of the common errors. We shall now move on to visualization of your workflows for easier troubleshooting. As your LangGraph workflows grows in complexity, it becomes increasingly important to visualize how data flows through your graph. Visualization helps you see how nodes are connected and how data moves between them and where things might be going wrong. LangGraph integrates with LangSmith, a tool that helps you visualize your workflows and trace how data moves through your graph. This graphical representation of your workflow makes it easier to identify issues and understand why certain nodes aren't executing as expected. Here's how LangGraph's workflow visualizations can help you debug. When you run your LangGraph application with LangSmith, you will be able to see each node and its state at each step. This allows you to track exactly what data is being processed from one node to another. If a node isn't executing correctly, you can click on it in the LangSmith visualization and see why. Did the previous fail to pass the correct data? This information helps you quickly identify where the problem lies. LangSmith allows you to see the history of state changes as your graph runs. This helps you pinpoint when and where the state is being modified and if there are any unexpected behaviors along the way. Here are some of the best practices for troubleshooting. Debugging can be a challenge, but there are several best practices that you can follow to make it easier and be more effective. So you need to start small and build up. When you begin building a graph workflow, it's best to start with a simple, minimal graph. Focus on getting one node or a task working perfectly before adding more complexity. Once you have a basic graph, gradually add more tools and connections. By starting small and building up, you reduce the chances of encountering overwhelming issues that are hard to debug. Secondly, use unit testing. Unit testing is a technique where you test individual parts of your code in isolation. This means testing each node separately to ensure it behaves as expected before connecting it to another node. This makes it easier to identify where things go wrong and helps you catch errors early. Then, break down complex graphs into subgraphs. As your workflow grows, it can get difficult to keep track of everything. To avoid complexity, break down your workflows into subgraphs. Each sub should represent a smaller, manageable part of your project. This modular approach makes it easier to debug specific sections of your graph without having to sit through the entire workflow. For example, if you're building a multi-step assistant, you could break it down into subgraphs like user authentication, user preferences, and user questions. This will allow you to focus on one part at a time and troubleshoot more effectively. Use logs for tracking data. Next, use logs for tracing data. Logging in is your best friend when it comes to tracking down issues in your graph. By adding logging statements in each node, you can track how data moves and what's happening at each step. This will help you spot where things go wrong and fix them quickly. So finally, debugging LangGraph applications doesn't have to be a daunting task. By understanding common errors, using tools like LangSmith for visualization workflows, and following best practices like starting small and using unit tests, you can troubleshoot efficiently and keep your graph running smoothly. Remember, debugging is not just about finding mistakes, it's about improving your graph, optimizing performance, and making sure your AI is working as expected. The more you practice debugging, the better you will get at finding and solving issues quickly. Keep experimenting, testing, and refining your LangGraph projects, and you'll soon be able to build more complex, reliable AI systems that remember context and interact intelligently with users. Debugging is a skill that you will continue to refine, and with these tools and strategies in hand, you're well equipped to handle anything that comes your way. So we will now start up with setting up your first LangGraph project. In this section, we'll go through the installation process, setting up the environment, and finally, creating your first LangGraph project. So for the first step, you will have to install Python and create a virtual environment. So before we begin, ensure that you have Python 3.10 or the above installed on your system. If not, head over to the official Python website and download the latest version. You will also need to install PyCharm, which is one of the best integrated developer environments for Python. If you're comfortable with another IDE, feel free to use that instead. But PyCharm makes the setup easier. So once you have installed Python, open your command line interface and create a new directory. So the directory has been created. Now we will create a virtual environment. Think of a virtual environment as a sandbox where you can install Python libraries specific to your project without affecting the rest of your system. So to create a virtual environment, run this command. So with this, we've activated the virtual environment. Now that's been done. Now that has been completed, we will now activate the virtual environment. So on Windows, you will use this particular code. So as you can see, we're within the LangGraph environment. So this will be the code if you're operating on macOS or Linux. So now that we're within the environment and it's activated, you will see LangGraph env right before the command prompt as shown here. So this indicates that you're working within the virtual environment. Now for the second step, install dependencies. Now we will have to install the necessary libraries. LangGraph relies on a few external libraries such as LangChain and OpenAI API. So in order to install them, run the following commands in your terminal. So I will be doing it here as follows. The OpenAI API is required for generating AI responses, which we will use to create a dynamic conversational system. We shall now move on to creating our first graph. We shall now move on to the third step, which is creating your first graph. So here's what you're supposed to do. Now that the environment has been set up, it's time to create your first LangGraph project. Let's start with a simple Hello World graph. First, create a file called helloworld.py in your project directory. So this file will contain all the code for your first LangGraph. So open it and add the following code. So finally here we are printing the result. For the last part, we have compiled and invoked the code here as seen. So I shall now explain the terminologies behind the code. So the state class is created using this, which is specifying that the state must contain a message key of type str. So this ensures that the state passed around the graph is always following the structure. So for creating the node function, so the function hello world here takes the state as an input and returns a new state where the message is updated to hello world. So this function defines the behavior of a node in the graph. Then for the third part, which is creating a graph, a state graph object is instantiated using a state class as a template. This defines the structure of the graph and how the state flows through different nodes. For the fourth part, we have add nodes and edges. So the hello world function here is assigned to the hello node in the graph. The edges are defined to connect the graph's nodes, where the process starts from the start node and goes to the hello and then from hello to the end, establishing a flow of execution. Lastly, we have compile the graph. So the compile method prepares the graph for execution, ensuring that all nodes and edges are correctly set up. So it generates an executable graph object that can be invoked. Finally, we have invoke the graph. So the invoke method is called on the compile graph object by passing an initial state with an empty message. So the graph is then executed and the hello world node updates the state, producing the result which is printed here. So as you can see, when you run this file, you should see the output, hello world. So this is your first LangGraph working. We shall now move on to building an AI assistant using LangGraph. Now that you've set up your first LangGraph, let's build a talking AI assistant using LangGraph. We're going to make a simple assistant that can remember your name and greet you. So the key feature of any smart assistant is the memory. The assistant should be able to remember your name and refer back to it during a conversation. In LangGraph, memory is handled through state. We'll modify the hello world function to ask for the user's name and store it in the state. So here we're inputting what is your name. Then we shall return username as username. So in this code, we ask the user for their name and store it in the state under the key username. Now that we have the user's name stored in the state, let's create a second function that greets the user. So this function uses the stored name from the state to greet the user by their name. For the third step, we will link the functions. Now we need to link these two functions together into a workflow. LangGraph makes it easy to link nodes by running them in the sequence. So I have attached a cleaner code over here in place of the previous one. So what you will have to do is we will go ahead and run the code. So here it asks you what is your name. So let's just say I type in my name as Alice. Here you get the output as hello Alice. So when you're running the code, the assistant will ask for your name, store it, and then greet you. It's simple, but this forms the foundation of any conversational AI system that remembers context. So in order to make our assistant smarter, we need to add stateful logic and conditional jumps. These concepts allow the assistant to make decisions based on user input and maintain memory across different stages of conversation. So for the first step, which is conditional logic for decisions, let's say the assistant needs to ask the user if they want to continue the conversation or not. So depending on the user's response, the assistant should either continue chatting or end the conversation. So this is where conditional logic comes in. We'll create a function that asks the user if they want to continue. So here I will type in, do you want to continue the conversation? And then within brackets, yes or no. Added a fresh code over here. So if the user types yes, the function will return true. Otherwise, it will return false. So let's just say I type my name here as Alice. So let's start. Here we have to type in your name again. So here you get an option where they're asking you, do you want to continue the conversation, yes or no? So here you can type yes or no. I will go for yes. So as you can tell, when I typed the line, it returned the same conversation again. But when I type no, it says goodbye Alice, see you later. So by that we can tell if the user types yes, the function will return true, otherwise it returns. So once you type Alice, it says, hello Alice, do you want to continue the conversation? Where I say yes. Let's just say I say no. It says goodbye Alice, see you later. Okay, that's all. Anyways, for the next step, we will move on to handle the decision. Now we will create a function that makes a decision based on the user's input. So if the user wants to continue, the assistant will greet them again. Otherwise, it will say goodbye. So whatever I told just now, please place it before whatever I executed here. For the third step, link everything together. Now that we have three functions, one to ask for the user's name, one to greet the user, and one to handle the continuation of the conversation, we link them all into the single graph, as shown over here already. So this simple decision-making capability makes your assistant feel more dynamic and interactive. We shall now move on to integrating tools like LangGraph, LangChain, Pinecone, and Hugging Face. At this point, we've built a basic assistant that remembers user input and make decisions based on that input. But what if you give it more power, like searching through documents and providing answers? That's where tools like Pinecone and Hugging Face come into play. Pine is a vector database that allows us to efficiently store and search through large data sets. Hugging provides state-of-the-art machine learning models that can perform a wide variety of tasks, like text generation and question answering. So let's start by integrating Pinecone into our project. First, we will need to install the Pinecone client. So for that, we will have to move into our terminal here and type pip install Pinecone client. Once it's installed, we can initialize Pinecone and create an index for our documents. So for this, move on to your IDE again. You'll open a new file. So what you will have to do is, now that Pinecone has been installed, import Pinecone. So as you can see, we have searched the documents and for relevant documents based on a user query, which I will type it out here. So this function queries the Python index and returns the most relevant document. Then we move on to integrating Hugging Face. Next, we can integrate Hugging Face to generate intelligent responses. So first, you'll need to install the Hugging Face Transformers library. So I will do that over here. Move into your terminal and type pip install transformers. Then we can use Hugging Face models to generate answers based on the documents returned from Pinecone. So while this is being installed, I will just type the code. So here we have the code. So in this code, we will use a question answering model from Hugging Face to find answers based on the context retrieved from Pinecone. So this enables your assistant to answer the questions by searching through large data sets. We shall now move on to some common errors that we encounter and how we can solve them. So for the first one, we have missing or incorrect states. So one of the most common errors that you will face in LangGraph is a missing state error. So this happens when your graph tries to access information in the state that hasn't been initialized yet or doesn't exist. So in other words, you're trying to use data that hasn't been provided. So for example, imagine that you have a node that's trying to access this particular line of code, but the user hasn't provided their name yet. So the error will happen because the LangGraph is expecting a piece of data that isn't in the state. So this results in the application failing unexpectedly. To prevent this from happening, you should ensure that the state is properly initialized before you attempt to access any data within it. So one way to handle this is by checking whether the state actually contains the required data. Here's an example of how you can handle this situation effectively. So we have this line of code over here. So in this example, if the state does not contain username, the bot will ask the user to provide it. This prevents the bot from breaking and ensures that it operates smoothly even if the data is missing. For the next part, we have empty or invalid inputs. So another common issue arises when a node is expecting an input, but the input is either empty or invalid. So for example, you might ask the user to provide their age or preference, but they enter nothing or it's an invalid value like a negative number. So when the input does not meet the expected format or it contains unexpected data, your system can crash or the behavior might not make sense. To solve this issue, you can validate the input before passing it to the next. This ensures that the data is both correct and usable. So here's how you can handle invalid input, such as asking for the user's age. So this line of code will help you do the same. Wherein in this example, if we check the age, it is a positive integer. If not, we prompt the user to enter a valid value. This validation step helps you ensure that the system doesn't crash or produce incorrect results. Thirdly, we have unreachable nodes. Sometimes when setting up your LangGraph workflow, you might notice that certain nodes never get executed because the flow of the graph is incorrect. So in other words, the edges between the nodes don't work as expected. And some nodes are actually left out of the process entirely. So here, as you can see, if your decision-making logic like if or else statement, is set up improperly, it may prevent nodes from being triggered. So if the node is unreachable, it means that there is some flaw in the graph or how it is structured or how the flow is controlled. Here's how you can solve it. To fix this, you need to carefully check your node connections and ensure that the logic controlling the flow is set up properly. So if you're using decision-making logic, ensure that all potential conditions are covered. So here is an example where we set up a simple decision point in the graph. So it's mentioned over here. So in this case, the flow depends on the response. So as you can see, in this case, if the response contains yes, the graph proceeds, otherwise it stops. So double check the conditions and the edges to ensure that all nodes are reachable and executed in the correct order. Thank you so much for joining today's session on LangGraph. We've covered a lot of ground, from setting up your first LangGraph project to learning how to create intelligent memory-powered AI systems. Now it's time to apply what you've learned and start building on your own. Let us know how you plan to use LangGraph in your projects, or if you have any questions, feel free to ask. And of course, don't forget to subscribe to our Simplilearn's channel so you can stay up to date on all our latest content on AI, machine learning, and much more. Keep experimenting, building, and learning, and I look forward to seeing what you've created with LangGraph. Happy coding!